Hello, everyone. In this final video for section 6.1, we're going to look at the two area formulas that we saw in this section. So keep in mind, or maybe just recall the two examples that we saw, looked at computing areas between curves. In example 1, the two curves that we looked at were curves defined as functions of x. So x was the input, y was the output, and we integrated along the x-axis. In example 2, we looked at the area between two functions of y. So x was our output, y was our input, and the integral that we evaluated over was an interval of the y-axis. So we're just going to summarize these two perspectives of looking at areas between curves. So A here says the area between functions of x. Again, so those are functions that look like f of x, g of x, and we even have them labeled here. So we have f of x here. We'll use highlighter. So f of x and g of x. And so we can use this little helper rectangle here. Notice the little width of a rectangle is going to be delta x or dx. And then we can notice the length of this little rectangle is going to be f of x minus g of x. So then the area is determined by the integral we're looking at from a to b of f of x minus g of x dx. So notice again how we're taking our slices where we're chopping up the x-axis into small pieces, and we're looking at an interval, integrating above an interval on the x-axis. So that's why we have our dx. So just some things to notice and keep in mind as little helpers for pointing at which variable we're using in our integral. All right, so now the second part, area between two functions of y. So recall functions of y look like our input now is y. So f of y, g of y. And so if we're looking at the area between two functions of y, that means, again, our input is on the y-axis. So if we look at a little helper rectangle, we're doing changes in y or d of y. So we'll have a d of y in our integral. And if we look at our function on the right side, f of y, and say on the left side is g of y, then the length of this little slice is going to be our larger function, f of y, minus our smaller function, g of y. So that'll look like the area will be the integral now from c to d, again, that interval on the y-axis now, of f of y minus g of y dy. And so again, we can observe our dy is that interval of the y-axis. So the dy corresponds, or the y, the variable, corresponds to the input of our functions, which also corresponds to the axis above which we are integrating over, or where these bounds are referring to. And so notice we should also have y's within our integrand as well. So there's so many patterns that we can look at in these integrals and identify with to determine which axis we're integrating over and which kind of functions we're looking at computing the area between. Okay, we're going to see some more examples of this as you work through the rest of these examples and exercises in our workbook and also in our homework this week. All right, thank you so much for watching, everyone. Keep up the hard work.